Hello friends, welcome to all of you in my YouTube channel Physics Cafe by Manjeet Kaur. So today's our topic is mechanics of system of particles, which is from classical mechanics. So for this topic, here we have XYZ plane whose origin is O. Here we have number of particles whose masses is m. Now for different number of particles, their masses is also different. For first particle, its mass is m1. For second particle, its mass is m2. For third particle, its mass is m3, and so on. Here we have ith particle whose position vector is ri vector, and for this jth particle, its position vector is rj vector. So in this space, here we have number of forces act on this. So which forces are acted on this are two types of forces. First is internal force and second is external forces acted on this. So let's start. Suppose we have a number of particles having mass m. That means for first particle, its mass is m1. Similarly for second particle, its mass is m2. For third particle, its mass is m3, and so on. Similarly, their position vectors is also for different particles. That means for first particle, its position vector is r1 vector. For second particle, its position vector is r2 vector, and similarly so on. Now we have two types of forces acted on this. So first is F external force plus F internal forces. That means two types of forces are, first is F external force and second is F internal force. which is equals to F. Now consider internal forces exerting on first particle due to particle second F12, F13 and so on. Similarly, for second particle, internal forces exerting on second particle due to first is F21, F23 and so on. Now, in general, forces exerted on ith particle is Fi1 plus Fi2 plus Fi3 plus equals to summation I is equals to I is not equals to j Fij. So total force acting on the ith particle is summation Ij Fij plus Fij external equals to dPi upon dt. Total force is the sum of F internal forces and F external forces. For F internal forces, here we have condition when I is not equals to j. That means summation Ij Fij internal plus Fij external is equals to dPi upon dt. Now, so total force act on all these particles are total force acting on all these particles are summation Ij Fij plus summation Ij Fi external is equals to summation I F dPi upon dt, which is our equation number 1. Now, first we solve this equation. let's say this is equation number A and this is equation number B. Now first we have solved A. So we write here summation Ig Fij is equals to summation I bracket Fi1 plus Fi2 plus Fi3 and so on Fin. Now we open this bracket, so we can write summation I Fi1 plus summation I Fi2 plus summation I Fi3 plus and so on summation I Fin. Now we can write F21 plus F31 plus and so on plus F12 plus F32 and so on plus F13 plus F23 and so on. From Newton's third law, we know Fij is equals to minus Fji. That means force on ith particle due to J is equals to minus force of jth particle due to particle I. Thus we get F12 is equals to minus F21. That means force on particle 1 is due to force on particle 2. Similarly, force on particle 2 is due to force on particle 1. Now, by using this, net internal force exerting on system of particles is 0. Thus we get summation Ij Fij is equals to 0, which is our equation number 2. So we put this equation here. So we get F internal force. Now we find the value of F external force. So for this we can write here total external force F is equals to Fe vector is equals to summation I equals to 1 d upon dt mi vi. So for this is our velocity. So we can write it as summation I is equals to 1 to n d upon dt mi d upon dt ri vector. Okay, so mi is constant. We can write equals to 1 to n d square upon dt square m1 r1 vector plus m2 r2 vector and so on mi ri vector plus mn rn vector. Now divide this equation by summation I equals to 1 to n mi. So we can write summation I equals to 1 to n d square upon dt square m1 r1 vector plus m2 r2 vector plus mi ri vector plus mn rn vector divided by summation I equals to 1 to n mi. Now I is equals to 1 to n, so put the values of I. Summation here we don't have to write summation, so we can get d square upon dt square m1 r1 vector plus m2 r2 vector plus mi ri vector plus mn rn vector divided by m1 plus m2 plus mi plus mn. Now here we have r vector, which is a position vector. R vector is a position vectors R is our position vector. Here we have number of particles, so here we have cth particle whose position vector is r. That means all center of mass is concentrated around this particle, so its position vector is r vector. Now we can write r vector is equals to summation I equals to 1 to n mi ri vector upon summation I equals to 1 to n mi. We know summation I equals to 1 to n mi is equals to m, mass of the particles. So we can write in place of this, we can write m. So right here r vector is equals to summation I equals to 1 to n mi ri vector upon m. So we get F external force is equals to, now we have to put this value here, so we can write Fe vector is equals to d square upon dt square upon dt square m into r vector. From here m goes to here, so we can write m into r vector. So r is our position vector of cth particle and m is the mass of that particle. So F external is equals to m d square upon dt square r vector, where this equation is equation of motion. Done. Now we can write d upon dt m dr upon dt. So we can write f external is equals to f external vector is equals to m d upon dt dr vector upon dt, which is equals to m dv vector upon dt. Here that is our velocity around central of mass. So similarly we can write Fe vector is equals to m into acceleration around central of mass, because F is directly proportional to acceleration. So here F vector is proportional to acceleration. So this is F internal for velocity. This is for external, F external for velocity and F external for acceleration. Now we have Pi, which is equals to Mi Vi, that means momentum is the product of mass into velocity. So when we take summation Mi d Ri upon dt, we can write d upon dt summation I Mi Ri, which is equals to d upon dt, we can write it as m Ri. Now multiply and divide above equation with summation I equal to n into mi. So we get m d upon dt summation I mi ri upon summation mi. Now we know this is our r, because we know r is equals to summation I equals to 1 to n mi ri upon summation mi. So put here the value of r, we get m dr upon dt. Thus this is the value of p. Thus force external is equals to dp upon dt. Now we know total force is the sum of internal and external forces. So by using this equation we know F internal, which is our equation number 1, which is our equation number 2. F internal's value is 0 and F external is this mdr upon dt. So we get f, so we can write it as summation ij fij plus summation ij fi external is equals to summation dpi upon dt from equation number 1. So put the value of f internal and f external here. So we get f is equals to dp upon dt, where p is conserved. So this is our article is complete. Our next article is conservation of angular momentum. So for this we have L, which is equals to R into P for single particle. We know torque is equals to R into F. And for system of particles, total angular momentum is summation I equals to 1 to j ri into pi. And similarly for this is for L, summation 1 to j. And similarly for total torque, you can write summation I equals to 1 to j n, ri into fi. So we can write summation I equals to 1 to n ri into, we know F total force, which is the sum of F internal and F external. So we can write Fi equals to 1 to n Fij plus Fi external, which is our F internal force and this is our F external force. So we open this bracket, we can write summation I equals to 1 to n ri into Fij plus summation I equals to ri into Fi external. So we can write summation Ij when I is not equals to j ri into Fij. Condition when we apply summation I is not equals to j. So we can write summation R1 into F1j plus R2 into F2j and so on Rn into Fnj. So we can write summation R1 into Fij plus summation j R2 into F2j and so on, summation Rn Fnj. So we can write R1 into F12 plus R1 into F13 plus R2 into F21 plus R2 into F23 and plus so on. So we can write F12 is equals to minus F21. Because of Newton's third law of motion. So R21 into F21, where R21 is equals to R2 minus R1. Minus R into F21 plus R2 F12 plus R2 into F21 plus so on. So from here we can write R2 minus R1 F21 and so on. So we can write this equation. We know F21 is central, then angle is 0. So we get Rij into Fij is equals to 0. So torque is equals to d upon dt summation I equals to 1 to n ij Ri into Fi external summation I equals to 1 to n d upon dt Ri into Pi. So this is our momentum, angular momentum. So we can write summation I equals to 1 to n d upon dt into Li, which is equals to dl upon dt. So we get dl upon dt when L is conserved. So we get this equation. So this is for our conservation of angular momentum.